Using Docker commit is an inefficient way to generate images for the most part. Docker provides another mechanism to build Docker images using the command docker build. Docker build relies on a file called a Dockerfile, which specifies a list of instructions used to build a Docker image. The commands that we manually ran inside our container to produce an image can be specified in a Dockerfile. This gives us a shareable, reproducible, and automatable recipe for building a Docker image. When we run docker build, Docker essentially creates a container from the base image and executes each instruction in the container and saves the changes to an image layer. Each line in the Docker file is an atomic commit. These layers are cached as the image builds. So changing an instruction in a Docker file will only cause the layers at and after the changed instruction to be rerun. This makes building a new image much easier as you do not have to start from scratch every time you build. Let's create a simple Docker file and try it out. For this lesson, we have a directory containing an empty Docker file and our average JavaScript application from the last lesson. Let's make our first Docker file. Docker files are always named Dockerfile with a capital D and no spaces. The first instruction in any Docker file must be the from instruction. The from instruction specifies which base image to use as a starting point for the image. We can pick any base image we'd like. For this demonstration, we'll just use the latest Alpine Linux image. Notice the instruction name is always in all caps. The next instruction we'll add to our Docker file is the maintainer instruction. This simply indicates the owner of the Docker image. This line does not at all affect the functionality of the container. So let's save our Docker file and try building it. To build our Docker file, we simply run docker build and pass the path of the Docker file as the argument. Since our Docker file is in the current working directory, we can just use period. We now see a series of steps building our image in the output. The first step is from our from instruction, and here we downloaded our base image. Below the step output is an image ID. This is the Alpine Linux image ID. Since we haven't made changes to the image yet, we haven't actually created a new image ID yet. The second step is our maintainer instruction. Even though this instruction adds no real functionality to our container, you can see below that it did create a new image. You can also see that it removed an intermediate container. That's because each step in our Docker file is run in a container, and then the container is committed to produce a new image. Although we've added no real functionality, we have just created a new image with a Docker file. We can now run the command docker images to see a list of our images cached locally. And here is our image. If we wanted to, we could run the image using docker run. Before we do, let's add a few more lines to our Docker file to make our image a little bit more useful. The Node application code from the last lesson is in the same directory as our Docker file. Let's look real quick. This should look familiar because it's the same code from the last lesson. It will simply average the arguments passed into the program. Let's edit our Docker file again, and this time we'll set up our image with Node.js and our Node application to achieve similar functionality as our image from the last lesson. In the last lesson, we shelled into a running container to install Node.js. Now that we're using a Docker file to build our image programmatically, we can use the run instruction to issue commands in our image. Run can be followed by any command or string of commands concatenated by a double ampersand. Here, we're updating our Alpine package sources and installing Node.js on the same line. This will produce one single atomic commit. Next, let's create the directory for our Node application using the run instruction. Now, we can add our JavaScript file to the average directory. We can add files from our local machine to the Docker image using the add instruction. For a file to be able to be added to a Docker image, it must reside in the same directory or in a directory below the Docker file. This is called the Docker context. Our average.js file is in the same directory, so we can add it. The first argument to the add instruction is the local file. We can reference the local file using a relative path. The second argument is the path inside the container to copy the file to. This can be relative to the current working directory in the container or an absolute path. We never specified a current working directory. We'll simply reference our average directory with the relative path. Next, we'll set the current working directory to the average directory using the workdir instruction. Workdir can take a relative or absolute path as the argument and sets it as the current working directory. And now that we've changed the working directory, any instructions in our Docker file will be executed in the new directory. This means that we can set our entry point to reference our JavaScript file without a full path. The entry point instruction defines the main process that will run within the container. The command specified in an entry point instruction is always PID1 inside the container, and the container's lifecycle will be bound to it. Notice that the entry point is specified as a JSON list. This is called the exec form. The exec form does not invoke a command shell, which means that we cannot include environment variables to be interpolated in our command. We will discuss entry points and commands further in a later lesson. Let's save and build our Docker file. This time, when we build our image, we'll give it a name. We can tag an image using the -t flag with Docker build. We now see that all of the commands in our Docker file have been executed, and we now have a working Docker image named rickfast/average. Let's run it. Since we specified our node app as the entry point to our image, we don't have to explicitly use it as our command. When an image has an entry point, any arguments passed to Docker run are passed the entry point as arguments. This means we simply need to supply some numbers to average. And now we have a fully functioning image for our average application. Baking the entry point into the image allows the consumer of our container to not have to care about the internals of the application. Distributing containerized applications allows us to write our programs using any language or runtime and not require our consumers to know, care, or have to install anything special. We'll discuss distributing our images later in this chapter.